Okay, so in this video we're going to be looking at parallel and perpendicular lines. Now any straight line can be given in the form y equals mx plus c. Okay, where m is your gradient, c is your y-intercept. The gradient is how steep your line is, and the y-intercept, c, is where your line crosses through the y-axis. Parallel lines and perpendicular lines are two separate things. Parallel lines will never get closer to each other, get further away from each other, or touch each other. And perpendicular lines are lines that meet at 90 degrees. So if I was to draw some examples, two parallel lines would look like this. And parallel lines are indicated with two arrows. And perpendicular lines, if I had one line like that, the other line would have to meet at 90 degrees, like so. And there's 90 degrees, there's 90 degrees, there's 90 degrees, and there's 90 degrees. So as we can see, all of these angles are 90 degrees, so the two lines here are perpendicular, and the two lines here are parallel. Now let's look at some exam questions. Okay, so this example, we're given a straight line, and it says we want to find the equation of the line parallel to this straight line. So y equals 3x plus 3 has a gradient of 3 and a y-intercept of 3 as well. That means for every 1 increase in our x values, we're actually increasing 3 in our y values. And the y-intercept means that we're crossing the y-axis at 3. So we're asked to find the equation of the line parallel to this. Now remember, parallel lines, they have the same gradient. Because like I mentioned before, parallel lines never get closer together, further away, or they never touch. So they must have the same gradient. So what that means is an equation of the line parallel to this line, we're going to have it in the form y equals mx plus c, where m is our gradient, and we can also write c as 3 there. So m is our gradient, and our parallel line must have the same gradient. So if this equation here has a gradient of 3, this parallel line must also have a gradient of 3, as their gradients have got to be the same if they are parallel. And then, because we're not told a point which this line passes through, we can actually have any y-intercept that we like. The only one we can't have, of course, is 3, because it would make it the same line. So you could have 2, you could have 100, you could have 90, you could have 40, you could have 4.962, and so on. You can have any y-intercept for this question. So that means I'm going to choose the parallel line 3x plus 2. Let's have another look at an example. Okay, here's the second example, and it says find the equation of the line perpendicular to y equals 4x minus 6. So remember, perpendicular means that the two lines meet at a right angle or meet at 90 degrees. So what we can say about the gradient of this line is that the gradient is 4, and that the y-intercept, be careful, don't forget the negative sign, is minus 6. So therefore, m is 4 and c is minus 6 for the line given. But we want the equation of the line perpendicular to y equals 4x plus 6. So that means we want the equation of the line that meets this line at 90 degrees. Now, perpendicular lines, the gradient of a perpendicular line is the negative reciprocal. So what is the negative reciprocal? Well, let's have a look at it in terms of this example. We have a line here and we're asked to work out the equation of the perpendicular line to this line. So if we take this m value here of 4, that's the gradient of this line. Now our parallel line will have the negative reciprocal of 4. Now any whole number we can write over 1. And then if we were to take the reciprocal of that, we'd have a quarter. Just flipping the fraction, bringing the 1 over to the top and the 4 under to the bottom. So we have 1 over 4. But now we have to change this to a negative because perpendicular. But now we have to change this quarter to a negative because perpendicular lines have a negative reciprocal gradient. So that becomes negative a quarter. So the gradient of our perpendicular line is negative a quarter. And again, because we're not told any points that this perpendicular line crosses through, we're not going to know our c value. So we can just say that that's going to be y equals mx plus c in the form of a straight line. We know our gradient now is negative a quarter, so we can put that in as our m value. And then the c, again, we can just choose. So I'm just going to have 2. That is the final answer. Okay, here's a slightly different example. Example 3 says, show that the lines y equals 6x plus 14 and 2y minus 12x minus 24 are parallel. So I'm going to highlight the word parallel. And I'm going to write down what we've learnt in this video, that parallel lines have the same gradients. What I want to do is get this line and this line in the form that we can work with. And the form for GCSE that we can work with for straight lines is, of course, y equals mx plus c. So I notice that this line here is already in that form, so we don't need to do any manipulation of that line. However, this line here is in a form that we can't work with, so we need to somehow get that in the form y equals mx plus c. So that's the first step for this question. So here's the line, and what I want to do is get that in a form that I can recognise. So I want to get it into y equals mx plus c. So the first thing I'm going to do is add 24 to both sides. Then I'm going to add 12x to both sides. And now I want to hit y equals something. So I'm going to divide by 2 because I don't want 2y, I want 1y. Now we've got this line in the form y equals mx plus c. This line is exactly the same as this line, but just in a different form. So now we've got the line in a form y equals mx plus c, and we can work with that. So these were the two lines that were given in our question. And now what we want to do is show that these two lines are parallel. And like I said at the beginning of this question, they have the same gradients. So we can say here and here, m equals 6 on both lines. Therefore, y equals 6x plus 14. And I'm going to write this line in the form that we were given, 2y minus 12x minus 24 equals 0, are parallel. Okay, now let's have a look at a fourth example. The fourth example says, show that the lines y equals 9x plus 7 and 9y plus x equals 81 are perpendicular. So, I'm going to highlight perpendicular, as that's the key word to be able to answer this question. Perpendicular lines meet at 90 degrees. Previously what we learnt is that perpendicular lines have a negative reciprocal gradient. So again, we're going to get both of these in the form y equals mx plus c. This line is already in that form, so we don't need to do any manipulation. However, this line is not in the form y equals mx plus c, so that's the first step for me to do this question. So 9y plus x equals 81, and we want that in the form y equals mx plus c. So we're going to rearrange this equation here to get y as the subject. So first thing I'm going to do is I'm going to say 9y is going to equal minus x plus 81. And I put the minus x here because in our y equals mx plus c, the x comes before our constant term. Now let's divide by 9. So we're going to get minus x over 9 plus 81 divided by 9 is 9. What I'm going to do with this divide by 9 is I'm actually going to bring it out and write it as the coefficient of x. So I'm going to say y equals negative 1/9 x plus 9. So this line here is exactly the same as this line here, but now we've got it in the form y equals mx plus c. So those were the two lines that we got given in our question, and we've just rearranged this line to give us that. And now hopefully you notice that looking at the gradients of the two lines, the negative reciprocal of 9 is actually minus a ninth, because remember 9 can be written as 9 over 1. Flipping this fraction to give us the reciprocal is a ninth, and then adding that negative value on there. We've now got negative a ninth. So we can say as the two lines have the negative reciprocal gradients of each other, they are perpendicular. And that's your final answer for question 4. Hopefully now you can do parallel and perpendicular lines.